Hello, today we're going to look at perpetuities. Now, perpetuities are used for people who have a lot of money to invest, and it's basically an interest-only investment. So, you hear of people who say they're going to, if they win tax lotto, they're going to dump it into a high interest savings account and live off the interest. That's what this is basically. And it's what a lot of scholarships are. So, somebody rich and famous dies, they might leave a scholarship, they might invest $1 million, but that $1 million always remains in the account and only the interest comes out. And the highlighted thing I put in here, if the payment received is exactly the same as the interest earned in one compounding period, the annuity will remain its value indefinitely. So the same value that was invested is always there, it's just the interest is coming out. That's what a perpetuity is. So here's the rule, the recursion rule that we're going to look at. V0, as we've been doing all along, is the initial value of the annuity. R is the interest rate per compounding period. D to be the regular payment received. And for perpetuities, the payment received is the interest earned. So in this case, the D is actually the rate divided by 100 multiplied by the value. So this is a really straightforward one. It looks confusing, but I'm going to show you how easy it is. All right. Calculating the withdrawal from a perpetuity. Elizabeth invests her super payout of $500,000 into a perpetuity that will provide a monthly income without using any of the initial investment. So that $500,000, $500,000 is going to stay in her account. If the interest rate for the perpetuity is 6% per annum, what monthly payment will Elizabeth receive? So there's a key point, monthly. So 6% has to be done monthly, so we have to go 6% divided by 12 first of all to find out what the rate's going to be per month. So that's what we've got down here. So V0 is the 500,000. The annual interest rate is 6%, but we need to do it for monthly. So 6 divided by 12 is 0.5%. So if we want to work it out, what you'll notice here, we haven't had to convert that because we're still dividing by 100. When I've been saying in my previous videos divided by 100, that's what the rule is doing there. You can divide it by 100 if you want first and then times it by $500,000. But that's how you're going to get that value. And that just means she's going to get $2,500 every month. Pretty straightforward. If you're a financial solver person, if you want to do it that way, I've seen students in the past really do this quite easily. So for a perpetuity, N is always going to be 1 because the payment's always going to be the same. All right. The interest rate's 6, so you can just keep it 6. You don't have to convert it because down here in the payments per year, this is where we're going to put the 12. And this is what the financial solver does. It does that 6 divided by 12 there for you. So it does that work for you. Now the principal, she invested $500,000. And this is where the good point is, if you put in the same amount but as a negative value, that just means it's always going to remain the same. So once I go to payment, if I click on that, there's the $2,500 that's coming your way. All right, so that's every single month. So this rule is quite simple, but if you get confused by dividing the interest rate by months or quarters or days, whatever, you can still use the financial solver. Here's another example. How much money will need to be invested in the perpetuity account, earning interest of 4.2% per annum compounding monthly if $200 will be withdrawn every month? Write your answer to the nearest dollar. Now this one's a bit trickier because as you'll notice, it's saying how much has to be invested. See how there's two amounts here? We can't use the financial solver for this question and this question alone. That's the only one. But we can use the solve function. So if I use the solve function, if I go menu, algebra, solve, what I need to do here is this. I can put in, we want $200. The interest rate, I have to go 4.2% divided by 12 because it's still per month, which gives me 0.35. So if I want to get up one of those up there, just like they put up there, all right, divisions. So if I go 0.35 divided by the 100, because that's still the percentage, it's still going to be divided by 100, and I multiply that by an unknown amount. So I want to find out what I have to invest. So remember, I'm just going to call it X, comma X, and I have to invest the 57,142 and 87 cents, or if it's the nearest dollar, 43. All right, so It can still be done in the CAS, but if you want to find out how much has to be invested for a perpetuity, you have to use a solve function. And it goes through some more of them. You can read that. That's sort of what I've covered on the CAS. And let's go to some questions here. Calculating the principal and interest rate of a perpetuity. Jeff wishes to set up a fund so that every year $2,500 is donated to the RSPCA in his name. That's like I was saying before, scholarships and things like that. This is what people do. So if the interest on his initial investment averages 2.5% per annum, compounding annually, how much should he invest? So once again, I've done that same thing there, and this is a different type of solve function I've done. I want 2,500, but you'll notice here I've already worked out the 2.5% divided by 100, and I put it there, okay? And I've multiplied it by V. Want to solve it for V, it gives me $100,000. So that's how much he'll need. In the next part, Part B, if Jeff has $80,000 to invest, what is the minimum interest rate he requires to provide for the donation in perpetuity? So this is where we use the finance solver again. So if I go finance, remember, one payment, we want to find out what the interest rate is. We don't know what it is. He's got $80,000 though. So I'm going to put in 80,000 here. And he wants to provide, well, that works out all right. He wants to provide 2,500. It's a negative amount. This is coming out. And remember, for a perpetuity, the PV and the FV must be the same. And it is done, annually. So down here in the payments per year, he's only going to do it once a year, so that has to be 1. So compounds and payments per year is just 1. We get up to the interest rate, which we want to find out. Oops, what have I done wrong there? So, oh, look at this. If you see a number like that, I just forgot to put a negative symbol in front of the 80, because remember, one has to be positive, one has to be negative. Go back up the interest rates. 3.125%. So he has to negotiate with his bank interest rate of 3.125% if he's only got 80 grand and he wants 2,500 per payment. And I'll do question 4 with you as well. This is that lottery type question I was talking about earlier. Craig wins $1 million in a lottery and decides to place it in a perpetuity. It pays 5.7% per annum interest compounding monthly. What monthly payment, correct to the nearest cent, does he receive? So you can see what I've already written there. Let's just fill in the details. We only got one payment. He can get 5.75% on that $1 million, so we've got to put in $1 million. And we don't know what the payment is yet. I also put in $1 million here. Negative this time, don't forget the negative symbol. And it's compounding monthly, so we've got to change these to months. So 12 payments per year, 12 compounds per year. Let's see how much money he can live off. So he's going to get $4,791.67 every single month just for that interest. And that just means that $1 million always sits in the account, but he just gets that interest. Best of luck with the rest of the questions.